Hello, this is simply about networking protocols, and today we are talking about VLAN. Standard that describes VLAN functionality is 802.1q. Whenever you looked for information about VLAN, you received those terrible schemas that are scary and terrifying with multiple devices, lines of different colors, that are making some crazy web. Well, it's true from the network point of view, but for verification, for us, this schema is enough. VLAN defines subset of ports that can exchange information with each other. In other words, we can say that VLAN is the slice of the device that contains ports that are members of this VLAN and allows bridging between those ports. So each VLAN we can define as a slice of the device with ports available only members of that VLAN. So frame processing is, you can imagine, like a frame gets onto the device sends it to respective slice, and on this slice we can select which port to proceed, ports, whatever it takes. VLAN tag frame format is Ethernet type plus VLAN info. Ethernet type for VLAN is 8120. VLAN info in this case, in this example, contains VLAN ID 10, that is R in hexadecimal, and frame called tagged if VLAN information is available, and untagged if VLAN information, VLAN tag is not available. By the way, following Ethernet type is used by the system to know should system perform any other actions toward this frame during the frame is processed by the system, other than just simple bridging by the VLAN. Main parameters that allows VLAN feature to work: PVID, port VLAN ID, or so-called default VLAN. System can receive on ingress untagged frame that doesn't contain VLAN information. But to decide to which slice eventually send this packet for processing, system needs some VLAN information. This feature is covered by PVID argument. PVID defines VLAN ID that will be added to the untagged frame by the system. And then this frame goes to respective slice and processed there. Ingress filtering. Ingress filtering verifies and drops packet that trying to ingress system through the port that is not member of the VLAN this frame is tagged with. In other words, in this example, and if ingress filtering is off, we send to port that is member of VLAN 1 only, frame tagged by VLAN 100. It will be received and transmit by one or two ports that are members of a respective VLAN 100. If ingress filter is on, and we forbid this operation, when port receive frame that is tagged by VLAN, this port not participates in, this frame will be dropped and will not be forwarded. Tagging. Tagging is egress argument. It means that port uses tagging option to verify towards frame that will egress this port or leave system through this port. And tagging means, so when we send packets through the slice, packet is tagged by this VLAN. If port is the member of VLAN in mode tagged, we let this tag stay in the frame, and frame goes out tagged. If participation of the port is untagged, we're removing this VLAN tag, and packet goes out as untagged. in this example, so port participates in VLAN 1 as tagged. We received frame tagged by VLAN 1. It gets to the port, it gets to the slice of the VLAN 1, it selects port to go out, and it goes out tagged. This port participates in VLAN 1 as untagged, and it goes out untagged. And one more VLAN related option, it's not exactly VLAN, but related and very important for it, it's so-called drop. Drop tagged, drop untagged, all and none. If drop is configured to tagged, we will drop tagged frames that are trying to ingress our system. If drop is configured to untagged, we will drop on ingress frames that are trying to ingress our system. If drop is all, we will drop everything. If drop is none, we will drop nothing. And this is very important because usually you will have to work with the system that doesn't allow you to configure all those options one by one, but uses integrated configuration options like access port and trunk port. Those are set of predefined attributes that are set when configured when we selecting port to be access or trunk. What are those predefined sets? In case access, port can be member only in single VLAN. PVID automatically equals to ID of this VLAN, of this membership, and drop configured to tagged. It means that when ports receive tagged frames, it will drop those, because access expects that behind this port something that not VLAN aware. And access is configured to operate with untagged frames, so it sends untagged frames because tagging mode is untagged. It sends untagged frames and expects to receive untagged frames, will tag it by respective VLAN, and will proceed send to the respective slice for a configuration. Trunk, on the example of the middle one. Membership, multiple VLANs, all possible VLANs in the system. There can be some deviations from provider to provider, what is allowed, what is not, but eventually all. PVID equals to so-called native VLAN. When you configure trunk, you also have native VLAN configured on your system, and PVID will use ID of this VLAN as an argument. Drop none, because trunk port expects to operate with tagged and untagged frames, and tagging for all VLANs except native VLAN it's tagged, for native VLAN it's untagged. Native VLAN, system VLAN, default VLAN, sometimes it can be different, but it is used to operate with so-called system control traffic. Again, different names can be used, and all other VLANs are data traffic usually. That's it. That's so simple. Thank you, and watch following videos.